Bonjour, Michel come from Switzerland, and today we will continue the code that we developed yesterday. So it's a session we do code live, and basically we will work on the Mycelium blockchain and implement all the functions. So yesterday what we did find out that we have to do a get ancestors function to be able to merge two blockchains. So let me remind you a little bit what is a blockchain. So a blockchain is a chain of documents, nothing else. It's linked document. You start with an initial document that we call Genesis. And so every document or every object in the blockchains are called blocks. And any type of document that refer to a previous version of it or another document with a reference, and if the reference is cryptographically secure, so meaning that we cannot corrupt it, then it's a blockchain. And so we start with a given block, Genesis, and we create one first document. And what we do is within that block, we refer to the Genesis block. So that's the little black rows that you see here. And so we do generate this document and linked it back to the previous one. Then we do update the document 0 and create a document 1. And we say, oh, let's put a reference to document 0 within document 1. And so this way, all those three blocks are chained together, hence the name blockchain. And so we can evolve the versions of documents several times, and even some people can take your document and then make some changes and have a separate branch of the document that live on its own. And so here you have Michel and Emile that have two documents and with the history of it described here. And so that means that everybody can have their own version of the documents. So there is no absolute version of the blockchain, beside that everyone has their own. And they know the most updated one with what we call it mutable pointers. So like we call head, it's the head of the chain. So Michel has the branch A, so the head will be head A. And then the Emile has the branch B, so the head of the documents chain is head B. Let me explain why we have to merge. So if everybody has their own version, then they might differ in some ways. For instance, that we can have one person that make an update, and then you have to merge that update with the main document or with the other person documents. And so how we do that? We do it by merging blocks. And the merging block means is that we have to identify what is the original source of the block, what is the common ancestors that was the same in terms of version, and then how they now differ, and then we will apply all the modification from one branch to the document that is the common ancestors, and we apply also the modification to the other branch to the same document. And so that means we will merge, we merge the versions of the modification, and leading to a document that is compatible with both branch. And so, for instance, the little green arrow is a merge of document 2B and document 2A, and that leads to document 3.0A. And so that's why there is the arrow that converge to this same document. Noting that the arrow is always pointing downwards, that means we point to the previous version. Because it's cryptographic hash, so we don't know the future, we know only the past, and so we can reference only the past. We cannot say doc2 reference doc3, because at the time that we made doc2, we didn't have doc3. So that's why all the rows are downwards. Alors, so let's do the merge, for instance, of doc3A and then doc3-1A with 3B. And so how we do that, we find out which one is common, doc1 is common, and then we apply all the changes on both branches. And that will lead to a doc4V. So we wrote the function yesterday. Let me get you, where is my code? Here you go. So we wrote this function CAA, closest common ancestors, that take the full graph and the two candidates for merge. And so we get the ancestors of one candidate, we get the ancestors of the other candidate, and then what we do is we color the graphs. So we put all the ancestors of A in color red and all the ancestors of B in color blue. That means that there is common ancestors that will have the color purple. If I assume that the colors are additive, so red plus blue will be purple or magenta for the color expert. And so this is how we do search the common ancestor. And then within the common ancestors, we want to have the closest one, the closest to the top, so the one that is the fresher. And so how we do that is we simply get a counter for every node, and we do place a +1. We increment that counter on every parent. So the one that doesn't have or the earliest one, the closest one, will have only one parent and will have no are not parents from anyone, and that will be the counter 0. So then we look for what is the 0. So we increment all the parents of each node by 1, and the one that has the count zeros are the closest ancestors. So that's easy. So in terms of only the purple one, we go through only the purple one. And so that means we have to have a function get ancestors, and that's what we wrote yesterday. We have the function that do the marking of the colors, and I changed from yesterday. Yesterday we had a function get node to get the node with a certain attribute. Now I put the filter function, because we don't, the get node was working on the graph, and for instance, all the purple node, we don't have the graph of the purple node, so we have only the list of the purple node. So in that sense, we just get a filter function that takes all the database with the attribute of the node, the list of the node that we want to filter, and the criteria, the request, the search request for the filter. So the filter itself. So like I say here is that we want the closest ancestors, the closest common ancestors, and so we get the database of the attributes as an argument, the list of the purple nodes, and the test, the filter where condition, which is the counters for the nodes has to be equal to 0, and then gives us the closest ancestors, which we use then for the merge. And so we will write down the merge function a little bit later. Here you go. So we wanted to test that. And so to be able to test that, we have to get the, let me, I don't know if I can share my screen here. Probably I need to have a screen share, screen capture. Here you go. I need to close the Vim version, and so here you go. Let me close that, and screen capture. Let me close that, and let's go for instance here, and cd testing blockchain, no, mini chain. and I think I put the files in an example. CD example, ls cd cca. So I'm working on a Linux system, so for the people that are not familiar, it's just more command based, I mean compared to Windows. So here you go. So I have the CCA program. We can see this. The same than the one I presented with the get ancestor function. There is a graph that is in a dot format. That's how we wrote the pictures on the side, so the graph. We extract from the graph a database that is in the YAML. So we extract the network basically with the command dot again, bin dot to YAML, and I give the dot file dag. Well, that's hard to pronounce. Here you go. So here I have a YAML file, like it's just a representation of all the edge of the network. So like for instance, the head A has an arrow, an edge to V4B, and so on. And you can see, for instance, V30A has two edges, so two parents. One is V2A and one is V2B, because there was a previous merge. Okay, so then we do start the command. So all those scripts are Perl scripts, so we run it with Perl, the name of the script, and then the name of the data, the network, the graph database YAML file. And here you go. And when we say, it says the DAG. The two ancestors are of the chosen node are doc v2b, and so I have hard coded the ancestors, but maybe we can do as arguments. So we want to merge two nodes. So let's do let's place like a shift. And this one also a shift, so that we can have argument to choose different nodes to compare with the graph. So for instance, if I want the common ancestors of 3b and 3, well, that would be the same because there's a 0. Let's say 5b and doc v2. Okay, so let's do that. So Perl CAA doc 5 v5b and doc v2a. Empty, non-existent. I don't have the 5b. Where is my oh, I didn't have it. EOG DAG PPN. So 5b is empty or non-existent. Oh, because we have to have the graph. I need to have 3 arguments. That's why. And we need to do the DAG dot YAML. There you go. So this says the doc v1 that is the common ancestors. So let's have a look. Doc v1 is the common ancestor on this and this. Yes, that's true. We can also play some trick like the common ancestor of v30a and v2a, and that would be probably the same doc v1. So v3, let's say v3 1a, and because it's a little bit up in the chain, so that will be even more a better test. And then what did I say, 2v, v2a, sorry, and it's v1v. Perfect. So the script is functioning perfectly. There you go. So now if I go back and remove my full screen, yeah, I'm using OBS for doing this, and put back to, where is my code? The Vim. There you go, the Vim. So that's it for now. And so we add basically the test case for that blockchain. Thank you very much. Bye bye.